Okay, we're going to jump into lesson 21.3, which is going to be on the hypotenuse leg triangle congruency theorem. This is going to be similar to some of the triangle congruency theorems that we've been looking at, although it has a slight difference in that we're talking about right triangles here, and we would know that because, right, we've got hypotenuse here. And so there's kind of three criteria to prove that these two triangles are congruent. It says if the hypotenuse and a leg of a right triangle are congruent to the hypotenuse and a leg of another right triangle, then the triangles are congruent. So there's three pieces there, right? The hypotenuses have to be congruent, they have to have a pair of congruent legs, and they have to be right triangles, right? So they've got to be right triangles in order for this to work. And so if you look at the image that we've got drawn here, we've got two right triangles. We know that because we've got these little boxes in the corner telling us that those are right angles there. So we've got the right triangles. The legs are either of the sides connected to that right angle. So in this case, it's the one going up and down, the vertical side here and the vertical side here. Those are the legs that are congruent. And then the hypotenuse, that's across from the 90-degree angle, and we can see that those are also congruent. So if you forgot, right, this is something you're going to want to remind yourself of. The hypotenuse is always opposite the 90-degree angle, right? So it's across from the 90-degree angle there, okay? And those have got to be congruent. And then we can say that these two triangles are congruent to each other, all right? So it says for this first one, determine whether there is enough information to prove that the triangles VWX and YXW are congruent. And then they've given you this image. Notice I've already drawn over this image, and then I've split it up so you can see these two triangles kind of separately here. And remember, there are three criteria to use the hypotenuse leg. First, are they right triangles? So are these right triangles? Right triangles. Okay, and we can see that they are because they have the little right angle marks here. So we know these are right triangles. Okay, so I'm going to give that a check mark. All right, and then next, do they have congruent legs? Do they have a pair of congruent legs? And we can see that they do, right? They've noted that we've got these two legs here, right? That's connected to the right angle, and they're congruent to each other. So that's a check mark there. And then it says, do they have congruent hypotenuse? So that's the last piece that we need here. Okay, do they have congruent hypotenuses? And for this one, we know that it's true because notice the hypotenuse, the side that is opposite the 90-degree angle for both of these, okay, is the same side, right? It's both WX, so of course these are congruent to each other, so I'm going to do the double tick mark to show that they are congruent, okay, and so then that's a check mark, and so then yes, we can say that these are congruent by the hypotenuse leg theorem because it meets those three criteria. Let's look at that in a proof, okay. You can pause this, write down the given information, which I've already done here just for the sake of time. It says angle J and angle L are right angles, right? So I put that down as my given information, and we can see that they've already marked that here on my image, J and L as right angles, so that's good. Okay, it then says K is the midpoint of JL and MN. Okay, so K is the midpoint of JL, which is this horizontal line here, and then NM, right, which is going to be going diagonally there. Okay, and it's the midpoint for both of those. So that's a lot of information that they're giving us there, and we're going to decipher that in a second. First, I want to start by looking at the criteria. Are these right triangles? And we know that they are right triangles because they have right angles, and I'm going to make a note of that because remember, that's something that I have to show is that they're right triangles. So I'm going to say angle or triangle JKN and triangle LKM are right triangles. And that's because they have that right angle. So I'm just going to put definition of right triangles. Okay. All right, so we've got those pieces there. Let me just separate this a little bit so you can see the different pieces there. Step 1, step 2, step 3. Okay, so that we've got the first criteria all ready to go, which is that these are right triangles. So now we have to decide, okay, do they have a pair of congruent legs? And remember, they told me that K is the midpoint. So if I zoom in on my picture here, if K is the midpoint of JL, then this half over here, J to K, must be the same as this half over here, L to K, because K is in the middle, K is the midpoint there. And so I'm going to go ahead and make that statement in my proof. And that statement is that JK is congruent to LK, and that's the definition of midpoint. Okay, so we've got the congruent legs there, and now we can keep going because remember they told me that that K is not only the midpoint of JL, it's also the midpoint of MK. So I can make some tick marks there, double tick marks there, right? Because it's also the midpoint going in that direction, which means that NK is congruent to MK. And again, that's the definition of the midpoint, so we use these little apostrophes here to show it's the same thing as above, right? If you haven't seen that, it just means that it's the same statement as above, so that's another definition of the midpoint there. All right, so we're getting closer there. And then we can go ahead and take a look at what we've got now that we've made these statements here. Well, we've said that they're right triangles. We have a pair of congruent legs. We have a pair of congruent hypotenuses, and so then that's going to be enough to say that these triangles are congruent by the HL theorem. So I'll make that final statement here. Triangle JKN is congruent to triangle LKM, and that's by the HL theorem. All right, there's that proof. Let's keep it going to the next one here. Once again, I've already written down the given information, so you can pause it and do that yourself. It says that CAB and DBA are right angles, and they've already got that drawn for me, right, in these two angles here. So we've got those right angles. It then tells me that AD is congruent to BC, and so I'm going to mark that onto my image here, AD. AD is this one going diagonally here, so it's kind of tough to see. AD is congruent to BC. And notice those are the hypotenuses of those two triangles, right? Just so you can kind of see the two triangles, if you can't picture them right now, we have one that looks like this, right? And then if I were to separate it, we have the other one that looks like this. And so what they're saying is we have these right angles, and then we have these congruent hypotenuses, which is AD and BC. So that's what we've got so far, right? And so now we just need to show that we have a pair of congruent legs, and of course we know that's going to be the case because we know that this side here, AB, is the same for both triangles, right? It would be these top pieces here on the triangles that I've drawn. And so I can say that AB is congruent to AB, AB is congruent to AB, and that's the reflexive property. Remember when something is congruent to itself? Reflexive property of congruence, POC, property of congruence. And so now we have the three pieces, right? We've got that these are right triangles, which I should state here. Triangle ABC and triangle BAD are right triangles. Because they have that right angle, we know that's the case, so I'm just going to put definition of right triangles. Okay, so now we know that they're right triangles, we know that the hypotenuses are congruent, and we know that they have a pair of congruent legs, and so then we can say that they are congruent triangles. So that would be triangle ABC is congruent to triangle BAD, and that's by the HL theorem. All right, sliding down here. It says you draw a right triangle with a hypotenuse that is 5 inches long. A friend also draws a right triangle with a hypotenuse that's 5 inches long. Can you conclude that the triangles are congruent using the HL congruence theorem? If not, what else would you need to know in order to conclude that the triangles are congruent? So remember, there's three pieces that you need. First, are they right triangles? So we can ask ourselves, are they right triangles? Right triangles. And we know that's a check mark because it tells me right here, you've drawn a right triangle. Okay, it says that you draw a hypotenuse that's 5 inches long and your friend draws a hypotenuse that's also 5 inches long. So the second question is, do they have congruent hypotenuses? And that's going to be a check, right? Because they're both 5 inches long. And then the last piece is, do they have a pair of congruent legs? So do they have congruent legs? Right? And that's what we don't know here, right? We don't know if that's true. They haven't given us any more information. So that's what we would need to know if we were to make this conclusion that they're congruent by the HL congruence theorem, right? So it says, if not, what else would you need to know? And this is the piece that we would need to know. Do they have a pair of congruent legs? And so that's that one. And then the last one is kind of a summary of all these theorems that we've looked at for triangle congruency. It says, how is the HL theorem similar to and different from ASA, SAS, SSS, AAS triangle congruence theorems, right? Because they all have similarities and they all have differences. And so what I'd like to do is to give you a second to think about the similarity and a difference between the HL theorem and the other theorems, and then go ahead and jot it down and we'll talk about it at class and share out there. All right? Okay, thanks for watching.